All right, guys. So in this case, I want us to consider our recap again on our filter circuits, just adding one or two things in our revisions. But as you can see, your N4 as it is just your recap that you need in your N5. So they're saying a full wave rectifier has an output. Take note, it's a full wave rectifier that you're considering there. And it has an output with VM of 12 volts. So as we are given the output of it, that's VM, okay, from the rectifier, filtered by a capacitor of 100 microfarads and supplies a load of 1000 ohms, given that the AC supply frequency is, which is the AC supply frequency is given. So remember from your rectifier circuit, when you've got your output and that output of a full wave rectifier, it is now the one that is entering the part of what? The filter. This is where you'll be having the filter circuits to the filter circuit to the what? To the load resistor and so on. So this is what you're going to have, where this now is the filtered part. And this is our capacitance. So this input that we have is the output of what? The full wave, which is an output that one. This is the input that we have, which was the output. And it's given as what? As VM, which is 12 volts. So the first question, we are given the capacitance value and also our RL is there. Remember, this is 100 microfarad, the resistance value, which is 1000 ohms. And the frequency, which is the AC frequency, considering the AC frequency, this is given as what? 50 hertz. Determine 1A, that is given the ripple peak-to-peak voltage. How are we going to have this for a full wave? All right, remember from our N4, it is like this, guys. This is what I just want. It's only that this is no longer clear, guys, the part that I wanted you to see. You calculated this peak-to-peak ripple voltage from IDC over to FC, if you still remember. But you're going to take a consideration that this is the one that you're also using for a full wave again, for a half wave and for a full wave. But in this case, we are going to make an assuming, we are going to assume these diodes ideally for ideal diodes. So this IDC at that moment of being ideal is going to be given as VM over RL at that moment, which is that maximum that we have when they are ideal. So means in place of this IDC that we used to in your N4, you are going to now use it as what? VM over what? Over RL. So that is the formula that you're going to have. So it's going to be VM over 2FC RL. That is the one that you now have. You make an assumption of these diodes to be what? To be ideal. So meaning to say at the end, as we saw our formula, it will end up with the ripple peak-to-peak voltage as VM, since we are considering VM in that case, over 1 over 2 FCRL. So with this, we can just substitute our values. The F that we're talking about in this case, this one, is the AC frequency. Remember, there's a relationship that will relate the AC frequency and the ripple frequency, but this one is the AC frequency that we are relating, which is the one that we are given there. So this was going to give us the value of our ripple peak-to-peak voltage, considering VM, that is 12 over 2 F, which is our AC frequency, 50 times the capacitance value. Remember, that is 100 microfarad times 10 to the exponent of -6 times RL, which is the value of the load resistor, which is 1000. And with this, you are going to obtain, this was going to give us 1,2. So you're going to have 1,2 volts if you simplify this properly. Okay, then we move on to another part, which is the RMS ripple voltage. How are you going to have this RMS ripple voltage? This is for a full wave. So the formulas already they're given. Okay. So if you are to consider this, we talked about this, that RMS ripple voltage, RMS ripple voltage can be obtained from the ripple peak to peak voltage over what? 2 square root of 3. This is both for a half wave or for a full wave. You're going to have the value that you obtained here for the peak to peak ripple voltage. You divide by what? 2 square root of 3. As we had, guys, from our N4. Nothing has changed there. Okay, so that's our B. So in this case, we are going to have our ripple RMS voltage. As we saw from our formula, given the ripple peak to peak voltage, you simply have to divide by 2 square root of 3, which also you have to consider from your formula sheet. All right, I just need to see if it's going to be possible so that I can share this part of your formula sheet to check. All right, I wanted you to see this here. All right. Okay, this was for VRMS, which is VDC over 2. Not this one, not this one. There's another one. All right, we need where we have got the peak to peak, where we have the peak to peak. Okay, there we have got this one. Okay, so if you consider here, where we have got the ripple peak to peak, this one. So these formulas are given, and there are so many formulas, guys. Considering our N5, our formula sheet has got a total of 6 pages. There's a lot of formulas. So we must at least have an idea of the topic so that if you're using those formulas, that'll be fine. But that is your recap from N4, guys. You understand that from N4, you also had a lot of formulas to consider. Anyways, we had this peak to peak. So you're just going to substitute. That is 1,2 over 2 square root of 3. So that was going to give us the ripple RMS voltage, which was going to be 0,346 volts. Okay, so with this, we can determine the next part, which is the DC voltage, which is our output DC voltage, which is the average DC. So also we can calculate this, if you still remember from our N4, we had this formula that we used of VM minus the ripple voltage, peak to peak, the ripple peak to peak voltage over 2. Okay, that is to calculate our VDC. If you still remember on VDC, VDC here on a full wave. So this one is on a full wave here. The Vmax there minus VRPP, which is the peak to peak over 2. So it can be calculated for a lot of things, but you have to consider what you are given in this case. From the information that you have got the peak to peak ripple voltage. The maximum, we have it, the VM, remember? So you're just going to substitute. That was going to give us the DC output, which is VDC, our VM, which is 12, minus our VR, which is the peak to peak. We got 1,2 over 2. So that was going to give us 11,4. Okay, so this one is going to give us 11,4 volts. Let's see the other part now. It is to calculate IDC, which is the current we're having. In this case, given that there is a load resistor of 1,000 ohms, and we have the VDC, we calculated the DC at the output. So what is going to be IDC? We can relate from that DC and the load resistor. There's a relationship between these two. So meaning to say the current will be the voltage at the output, which is our VDC over load resistance that we have there at the output. You're considering at the output. So VDC, we have it, that's 11,4 over RL. Load resistor given as 1000 ohms. So that is what you're going to have divided by 1000 ohms. We are now having our current. So that was going to be 0.0114, something like that. Which you can write in milliamps. 1, 2, 3 is going to be 11.4, something like that. Milliamps. Write it like that. 11.4 milliamps. 1, 2, 3 commas. It's going to be 11.4 if you multiply by 1000. So these questions, as you can see, they are simply a repetition that you need from your N4. So do not close those books for N4. Still need those notes. 1 or 2 things that you need to take from there. And E, they need us to calculate on this E. They need us to calculate now the ripple factor, which is R, the ripple factor. First, calculate using R is equal to this. Okay, then we're going to use another formula which has got this, but I'm going to talk about it. So they want us to use the ripple factor from the normal formula that we are used to. Okay, remember from our normal formula, the ripple factor is given from the ripple RMS over the DC. So that is first using that. Can you calculate the ripple factor? That is the question there. Okay, so we have got our formula, guys. As you can see also, that is the one that we were being given that is to use there. So using this formula, what is our ripple factor? All right, so this is E. So let's just have a question here. So according to this formula, the ripple factor is given from the ripple RMS voltage over the average DC, which is, we have got everything in that case. The ripple RMS, we calculated this. That was 0.346 divided to the DC. Okay, so our DC in this case, remember, it was 11.4. So that is it. So we're going to divide to 11.4. So that was going to give us the value of R, which is 0.030, like that. So we can write this as a number like times 10 to the exponent of minus 4 times 10 to the exponent of minus 3. You can write your answers in that manner, which is fine. But they're saying we can also calculate the same, then repeat by use of the formula in which R is calculated, directly from F, C, and RL. Which formula are we talking about? Remember, we had also this formula from our N3, from our N4. The ripple factor can be calculated from the formula which consists those frequencies and so on and so on. All right, so still remember this one. You are considering for a full wave rectifier. Remember, it's a full wave rectifier that we have, not a half wave. This one is for a half wave. So remember your formula, it's 4 square root of 3 FC, where this F is representing the AC frequency. So meaning to say we can just substitute into this formula. We've got our ripple factor. That is what they are saying there. The formula that has to consist with frequency, the capacitance value, and RL. Which formula is that? That is the one they are saying use it and see. So R is equal to what? That is 1/4 square root of 3 F C RL. Okay, for a full wave. For a full wave rectifier. We are told that this is a full wave. You must use the one for a full wave. So meaning to say, you're just going to substitute 1/4 square root of 3 times the frequency, which is the AC frequency. This one, it is the AC frequency. And our AC frequency is given as 50. The capacitance, 100 microfarad. The load resistance, 1000. Okay, so you're just going to substitute in that case. Remember, this was 50. The capacitance, 100 microfarad, 100 times 10 to the exponent of -6. The load resistor, which is 1000 ohms. So this was going to give us the value of R, which is 0.030. 0 to 9 like that, which is not like just a little bit different from what we had. Not exactly the same, but as you can see, it's almost there, just a slight difference. So the small difference that we see in the answers is due to the relatively large ripple voltage, which can cause that. Relatively large ripple voltage, which can cause that. So that's a very, very small difference that we are seeing there. So that was our question. Then on the other hand, they need us now to determine on F the minimum peak inverse voltage rating. So the minimum peak inverse voltage rating of the diodes considering of a full wave. The peak inverse voltage is equal to 2 times the maximum voltage. Peak inverse, I think we had that also from our info. Yeah, we had that. You still remember? Peak inverse voltage. Peak inverse. All right, I think it's not on these formulas. I'm just gonna show you this other part. Let me show you here from the formula sheet. Guys, I have a lot of this one. I have a lot of pages. Now I'll end up sharing the wrong page if I'm not wise here. This one is for a half wave. This one, when it is a full wave bridge, a full wave, this one, it's gonna be a full wave. Considering that we have got a full wave, then you're gonna use what? 2 times the maximum value in that case. All right. When it is of a half wave, in that case, you just going to use the maximum value as it is. Remember, we were told before that it is a full wave rectifier. So as long as you have to consider a full wave, it's going to multiply by 2. So 2 times Vm, remember our Vm, that's 12. It was going to give us 24 volts. So if you are to revise and go through your formula sheet to see the formulas that you're given and the formulas that you are given, understand what it represents, because you are not told that this is the formula for this or this is the formula for what. But this is just a recap, as we can see from our info, just 1 or 2 things that you can add, but as it was from info, just go through again from that part that we had. Just go through again. You'll see that is just a rare and no more. It's just a repetition as it is. All this you had, you had these calculations in your info. So let's start from there. As we move on, everything shall be clear.